Hello, everyone. Welcome back. I hope you are all doing well. We are back again with another Cloud Lunch and Learn session, and this time we have a special guest that is going to talk and tell us all we need to know about using event-driven architecture to empower startups, including the African startups. Okay, so without further ado, I would like to just bring on stage Moby to just let us know where he's connecting from. Hello, Moby. How are you doing?
You?
Sorry, you were on mute. I just unmuted you. How are you? All
Yeah,
good?
I'm good, bro. How are you?
All good, all good. So let us know where are you connecting from?
Yeah, my name is Chimaobi, and I'm connecting from Port Harcourt, like Nigeria.
Nice, nice. It's actually good that one of the main goals of this group is, as you know, this is a community group, and the idea is here is one of the main goals is to bring the diversity. That's why we try to go global and enable anyone in the world to be able to contribute to this group and to just join us while we are in our journey to learn more about cloud. So tell us, what are you bringing today, and why is relevant this topic to us?
Yeah, good day, everyone. So our topic today is how event-driven architectures can empower African startups. This is very, very necessary to African startups because Africa is the next biggest thing, like in tech. So we're looking at how to scale African startups, for to prepare them efficiently for scaling. And yeah, a lot of VCs have shown interest in Africa. A lot of VCs have tried to invest in Africa. They're angel investors now. And then popular programs like Y Combinator are coming to Africa. And we also have success stories from African startups like that was Paystack that got acquired by Stripe, over $200 million. So I mean, obviously, these guys implemented event-driven architecture. We also have like big startups like Jumia and M-Pesa, but these are African-focused startups. So like, for us to get the next biggest unicorn, the next big unicorn in Africa, we need event-driven architecture. I'm just here to like throw some light on it and just share my thoughts with you guys. So yeah, I'm ready to go when you're ready.
Sounds good. Sounds definitely. And the one thing that's probably I would like to add to that is, well, based on my experience with even event-driven architecture, probably we can say that these not only may help, the topic may not only help African startups, but probably startups globally, because one of the main benefits of this kind of architecture is the fact that it can help us build cost-effective solutions in the cloud. So that means we can actually scale while keep our costs as low as
Who
possible.
was
But
possible? Yeah.
anyway, without further ado, the stage is all yours as usual. For those connecting with us, if you are watching offline, as usual, you can connect with Moby. You will be sharing his contacts. For those that eventually join us live, feel free to use the chat to just share your questions, and we are going to try to cover those questions at the end of the session. But if something starts to come up too much, I will be sharing with Moby during the session as well. Okay. So I'm going to just enable your screen, Moby, and the stage is all yours. Okay.
All right. Thank you, Hugo. Thank you.
Thank you.
I take a hot minute to like appreciate the organizers of Cloud Launch and Learn. Without them, we wouldn't have this today. And big ups to Hugo. Huge shout out to Hugo for reaching out to me and making this possible. So yeah, without any further ado, I'm just going to jump right into it. So hello everyone. My name is Chimaobi, as I said before. And topic we're going to be dissecting here today is how event-driven architecture can empower African startups. So it's all about like just to get to know me. I'm a DevOps engineer, technical writer, but I also started off as a smart contract developer as well. So just a little bit about me. I also work as a startup technology consultant. So yeah, At the end of the session, I'll drop my contact information. So if anyone wants to link up with me, so yeah. So first is of like startups over here in Africa and startups in general face huge unique hurdles from unreliable internet connectivity to just handling sudden traffic, like during the holiday seasons. And the traffic usually just spikes as the user base grows. So today we'll be talking about event-driven architectures and like the solutions it offers to these lingering problems. So as the application expands and these if any services are introduced to your application, um sorry, I've lost my So yeah, as the application expands and services are introduced to your application, new services are introduced. The traditional request response model just becomes less efficient. A simple use case now is this: we have two possible connections. Service A and service B. Service A sends a request to service B. Service B processes and sends a response. That's your typical request response system. Um, but this system, however, if you try to scale it, you introduce more services to this system, it becomes exponentially complex. It's tough for it to grow. Now take a look at this. Now we have four services now. I mean, obviously, it could be four or more services. For each service, you have to like map a request and a response to them, and each service has to communicate with every other service in your system. And with each service, they have to all be aware of each other, and then this is a tightly coupled system. Disadvantage of tightly coupled systems. Once you have a single point of failure, your application can just go down. Um, Now the world in itself is event driven. The world as you know it is event driven. Think about the last 5 minutes of your life. The last bank transaction that you had. Your last M-Pesa transaction. The world is just event driven. Your email alert, your social media alert, each of these happened because there was an event that triggered a response somewhere. um, Now we move to event-driven architecture. So you're thinking, what is an event-driven architecture? An event-driven architecture just basically uses events to communicate between decoupled services. These are majorly found in services that are built on top of microservices. So the key thing I want you to take out of this is that with a microservice, you're just trying to communicate between decoupled services, from the generation to the propagation to the uh, reception of an event. That's just the key thing that you should take out of this, you know. And event-driven architectures are also just referred to as asynchronous communication, meaning that the sender does not need to wait for the recipient, in order for you to proceed carrying on his tasks. A very good example is just like a text message where you send a text message and you're not waiting for your recipient to acknowledge the message. You just continue on going on with your tasks. Um, Now the next thing we have here is what is an event? An event is it's just simply a change of state of the system. You know, Once something happens, an event is triggered. Let's say you send a text message, a user like books a ride, a user books a flight, a user orders for something, he likes a video, he likes a message, he watches a video, he pauses a video. These are all events. And the key thing to take out of events are immutable and they cannot be deleted. An event is just a record of what happened on a system. So you can't really delete it, neither can you like change it. It's just there, it just happens. And now I want us to walk through just what a monolithic application is and a microservice application is. A monolithic application is just a traditional model of a software program. It's just a single unit that's just self-contained. When you pack all your services, like all the services in your application, it's just in one application. That's pretty much a monolith. I mean, yes, there are a few myths to a monolith that we should debunk today, such that a monolith cannot scale. A monolith can't scale. You can scale vertically. You can beef up your servers, add more RAM to your monolith. But the major problem with monoliths is that you don't want to scale monoliths horizontally. There are a lot of problems coming up with scaling monoliths horizontally, and they're just horrible to scale. And that's where your microservices come in. Now, microservices um, are pretty much a collection of deployable services that are just independent of each other, but like they are loosely coupled together. They're just loosely coupled services that are on the same application, but they are not tightly coupled. So like just this is just an example where you have like different services. Like this could just be a service to, let's say this is a Netflix architecture. One service could like handle video playback, another service could handle your recommendation algorithm. Another service could handle, say, a user liking the video or a user like leaving a review on the video. So that's just basically what a microservice is. So yeah, we also have message driven architectures versus event driven architecture. I'd like us to just like touch on this as well. So with different microservices, there are different ways for them to talk to each other, and you can do this in messages. But a key difference between messages and events is that messages are mutable, and messages have to be queued. So you have a message queue or a message broker. In this case, a very very popular message broker we could use is RabbitMQ. So once you add a message to a queue, and then there's another services that listens for that message, and then it acts upon it, and then message leaves the queue, and then can be deleted, and then another message comes in. So messages are pretty much like commands, while events are just like records of what happened on your system. So yeah, it's like say a message is usually a command to do something, while with an event, it's just instructions and it's not information on what has. It's just instructions. So it's not any instructions, but it's just information on what has been performed by and by who. So yeah, you have your service here. Sorry, you have your service here and your messaging queue. Message comes into the queue, and once it's being executed, it goes out to the service, and then it's deleted from the queue. Another message can come into the queue. Then the main difference between a message-driven architecture and an event-driven architecture is that our service will always send the message after an event has happened, and then the service raising the event does not care whether the event has been acted upon or whether a service has been listening to it or not. But then it just fires the event. It just keeps on producing an event. Like if a user is booking a ride, the user is booking a flight. If three users are booking a flight, it's not going to wait for one user to make payments on the payment service. It's just going to just produce an event that okay, a flight has been booked. Another user comes and book the same flight, a flight has been booked, even if he hasn't made payments yet. So that's just what a an event-driven architecture does. But with a message-driven architecture, it's a command. So a user has booked a flight, so you should pay. So it's more like it's less of an asynchronous system than an event-driven architecture. And then yeah, the last key point here is that the service that's raising the event is not reliant on any other service to pick it up. So that's that's another difference between event-driven architectures and message-driven architectures. So yeah, that's I also want us to go through like differences between a request-driven service and an event-driven service. So in the flow control of a request-driven service, that's your typical request response application. It's synchronous. So like when you send a request, you're waiting for a response. If anybody's familiar with JavaScript here, and asynchronous programming, when you use your async, you have to await. So you have to wait for a response after you send like an asynchronous message or an asynchronous request. But like with your event-driven architectures, it's all asynchronous. Your event producer is just producing events, and then it's not really waiting for the event receiver or the consumer to consume these events and like bring back a response. It's just producing events. And then the communication model that you have for your event-driven architecture is, like I said, client sends a request and waits for a response, while over here the producer sends an event and then the consumer processes these events independently. And then on the coupling, you have tighter coupling with between the services. That's tighter coupling between your request-driven architecture, your request-driven service, and then is the applications or the services are loosely coupled in event-driven services. And then scalability, obviously, like this is one of the biggest selling points of event-driven architectures. Event-driven architectures can scale very well. It scales its independence, like scaling is independent of the producers and the consumer. Let's say there's a particular service that's having a surge. Let's say on your let's take YouTube for an example now. You have YouTube, and then there's a video that's going viral. So, okay, yeah, there's a very good example of this on Instagram. Back in the early days of Instagram, when Justin Bieber posted a photo, he always had a huge number of likes. So it got to a point in time where Justin Bieber actually broke the like counter. So you could just kill that part
Okay, it looks like we lost Moby. I hope it looks like it's a internet connection problem. Maybe some issue with the broadband. Are you back, Moby?
Yeah, can you guys hear me?
Now, yes, yeah. We just lost you for probably 30 seconds or something.
Yeah, it's probably like the internet over here. Okay, so yeah, back to what I was saying on scalability. So with scalability, and I was giving an example of Instagram and Justin Bieber. During the early days of Instagram, they had the like counter that went to a certain number, but then Justin Bieber had so many fans, and they had so many fans on Instagram, such that whenever he posted a video, he always broke the app. He broke the like counter of the app. You get. So like with the microservice, you could just kill that particular section that is responsible for counting the amount of likes or comments a post has, rather than having to scale up your whole application and then do the testing and the deployment process over again, just to get one feature, just to scale up one feature. Another very good example of this is like during the holiday seasons, where people are like placing orders left, right, and center. You could just scale that particular part of your system or your service that's responsible for handling order, or like that's creating orders or handling orders, or you could just scale up your payment systems rather than having to scale up your whole like entire application. And then with resilience, event-driven architectures are just more resilient than your request-driven architecture, your request-driven services. Due to lack of a single point of failure in your event-driven service than your request-driven service. So yeah, so we just move on to the core concepts of an event-driven architecture. You have the producer, your consumer, and your broker. So, what the producers do, producers just create and send out events, to inform other parts of the system that something has happened. You know, Examples of producers include mobile apps, your web applications, IoT devices. Let's take an e-commerce application for example. You have an order service. The part of your application that's responsible for creating an order, or it just produces an event that's like, okay, somebody has placed an order for something. So you also have your IoT devices and system monitors. System monitors are pretty much very useful when you're doing health checks on your system. So they just check that, okay, every single part of the system is up and running, and then if there's, let's say, some downtime, or like a particular service is not you know responding as it should, then your system monitors will produce an event and okay, tell the engineers that, okay, something is wrong here. Then you have your brokers. What the brokers do is they act as the middlemen. They manage the communication between the producers and then the consumers. Then they store these events produced by the producers and then ensure that these consumers, or the consumers that are subscribed to these events, can receive and process these events whenever they are ready to process them. Good examples include your messaging queues, your event brokers, and then you have your pub sub systems. This is just like publisher subscriber systems. Is a type of event driven architecture. Then you also have the consumers. Consumers just pretty much receive these events. They listen for and process these events that are sent by the producers, and then they act on it. They pretty much take some action based on whatever information was in that event. A good example of your consumers are processing services like delivery service. After you've placed an order, the ordering service would create an event, and then it goes through the message broker, and then let's say you have a processing service or delivery service starts listening to that event. um, it comes in as a delivery service. So I think I'm having some network issues here. Hello, can you guys hear me?
Yes, we can hear you. It's all good, Moby.
Okay.
Probably not now. Anyway, these are those things that can happen, as you know. So let's just try to give a minute for our friends Moby to just reconnect. In the meantime, I hope you are enjoying the session. This is definitely a really interesting topic. Personally, I have been using, um, when I say personally, professionally, of course, I've been using event-driven architecture for many, many years, especially on since I started to use Azure and cloud because as Moby described and as I mentioned before, definitely it's a way that you can explore to architect your solutions in a way that you can decrease the costs. So that means you can run your solutions in the cloud while ensuring an optimized cost and they ensure other benefits as Moby was saying, including the scalability. Of course, all of this comes with a price as well, especially the complexity. So depending on the size of application that you are trying to build, if you start to have dozens or hundreds of microservices and you need to connect them, then the management and the operation on daily basis of this may be a bit more complex, but it's definitely possible as long as you follow the best practice available on well-architected framework and the cloud adoption framework as well. So I think Moby is back. Hi,
Yeah,
Moby.
sorry. Yeah, sorry guys. I had like network issues. So I had to restart my router.
Okay,
So yeah,
all good.
okay. So yeah, picking up from where we stopped. So yeah, we're just going to just take a look at one of the biggest video streaming platforms to ever exist, Netflix. I mean, we are probably all familiar with the story of Netflix. Started as a little internet startup, took over the whole movie renting service from Blockbuster, back in the early 2000s. So currently, Netflix handles over like a billion events every day, and the platform uses event-driven architecture to manage multiple operations, from streaming data and like, from movie streaming to like data analytics and even to movie recommendations. There's a recommendation engine, and then now error handling. Just a little backstory. In 2009, Netflix faced growing pains. The infrastructure could not keep up with the demand for its rapidly growing services. So the company had to look for a solution and migrate its IT infrastructure from its private data centers, to a public cloud. So like they had to migrate from a monolithic architecture to a microservice architecture. I think Netflix they posted a video on YouTube, that started the whole like drive on event-driven architectures back in 2015, thereabout. Showing how they were able to overcome that particular problem. So yeah, let's take a look at Netflix and their infrastructure. So with every action that you take on Netflix, whether it's starting a new show or rating a movie or posting a stream, I'm trying to I don't know if you guys can see the diagram clearly.
Yes, probably if you can zoom in, do you have a possibility to zoom in the diagram a bit?
Yeah, I'm trying to see if I can do that. Is it any better?
It's not moving anything, to be
Oh,
honest.
all right, so I think we just work with what we have. So yeah, I was trying to see if we can improve on the diagrams, like to zoom it in, but I can't figure that out right now. But yeah, with every action you take on Netflix, whether it's starting a new show or releasing a movie or pausing a stream, it all produces an event, and like this event is gathered in real time and sent to like different services, such as the recommendation engine. For instance, when you start watching a new show, that event is immediately consumed by the recommendation service and then it updates your list with like similar content that you might enjoy. Then Netflix's architecture, continuously monitors the health of every service. And that's the health check I was talking about earlier. So if a service starts to slow down or it starts to fail, events are generated and like consumed by this monitoring service that to alert engineers or trigger automatic recovery processes. So by using an event-driven architecture, Netflix can handle massive amounts of real-time data and scale the services independently and ensure that users are receiving personalized recommendations instantly. Um, it's pretty much on the diagram too. You have a system event, and then this is just your event producer on your right. Sorry, event producer on your sorry to your left, and then you have a messaging broker in the middle, and then on the right you have consumers that are all just like subscribed to that particular event. So yeah, also going to take a very good look at another example here. We have Uber. So with Uber also is a, and we're all familiar with Uber, ride hailing service. Uh, Global is there in over 40 plus countries. So now Uber also like similarly operates on a massive scale. You know, it handles millions of rides across the globe every day. And it also uses event-driven architecture to manage both its real-time data processing and then its coordination between the services. So when the user like requests a ride, the ride is, and a ride request event is produced, and then the service is consumed by multiple services. The matching service finds the available drivers based on the user's location. The ETA service just estimates like the time of arrival, how long the ride is going to take. The pricing services calculates the ride cost based on factors like, say, distance or like demand. And that's where you also have like a surge price. And then like in each of these services, they all consume the same ride requested service or like ride requested event, but they respond in different ways. So additionally, Uber also like collects real-time data traffic, from by using telemetry events from drivers' phones. So this data is consumed by the routing service, which provides Uber's event-driven architecture allows the platform to process high-frequency events like rider requests, location updates, and then price. So, sorry,
Sorry,
I think
Moby.
I'm having some network glitches there. Can you guys hear me?
Yeah, yeah. Sorry, no, Moby. Your network is really unstable. Are you able to just connect something there that just close your apps and so on, just to ensure that
Yeah,
everything is
yeah. I'm trying to do that now, so hopefully everything is better from here on.
okay?
Can you guys hear me? Yeah. Okay. Good. So yeah, I was just talking about Uber basically, so each and every single one of these services, the matching service, the ETA service, and then the pricing service, all consume one event, that is the ride requested event. And then like using telemetry events, from the driver's phones, that's the data gotten from the driver's phones, Uber can also be able to allocate allocate you know these services that are subscribed to the telemetry events, to find the best routes, to follow for a particular ride. And other things like ETA too. We also used to improve the ETA to know how quickly a driver can complete a ride. So these are just examples of popular global companies using event-driven architecture. So we just like just break down, a very simple high-level breakdown of their architecture. And also the monolith to event-driven architecture transition strategy. Applying Gauss law with this. Gauss law says that every all complex systems that work, evolve from a simpler system that also worked. So you have to go from the known to the unknown. That's the way I like to put it. And so now, how do you want to transition from your monolith, your monolithic application, or your monolithic architecture to an event-driven architecture? So first off, you have to identify events. You have to identify the event producers and then the event consumers in your application. So you have to, okay. So if your application is let's say it's a e-commerce application, you have to identify, okay, what parts of this application or what services are going to produce events. So an event can be produced when, let's say, a user adds an item to a cart. So that's going to be an event producer. An event can also be produced when a user, let's say, likes an item or leaves a review on an item, or that's a rating on an item, or let's say user just simply purchases an item. So these are all event producers, and event consumers could be like your delivery system, or the inventory system, that okay, like, okay, one item has been bought, you have to take it off the, or you have to subtract the total amount of items by one, because like an item has been purchased already. So yeah, I also need to document the event flows. Like, so you have to like, okay, know how this event is going to flow from your producer over down to your event consumer. Then we are extracting the services now. So we have to start with the non-critical services, to extract them and then break them out and spread them out into microservices. And then you have to also maintain backward compatibility while implementing an event communication. So you have to choose the brokering services if you're going to use a messaging queue or if you're going to have to work with an event broker in this case. And then scale out. So gradually add more services, gradually move out, trade team members. And then you have to, also add monitoring to your system because like the thing with event-driven architecture based systems is that they're pretty hard to debug. So like you need very good monitoring systems in order to debug or like try to find faults because eventually there'll be faults. But the good thing with event-driven architecture is it's not going to bring a whole application down. But imagine, let's say you have an application whereby the logins is broken, the login service is broken, but then users can still okay, let's not say login. Let's say like you have an application where the registry service is broken, so you can't register new service new users, but then your existing users can still purchase items. Your whole application is not down, but it's partially functioning, and ideally we don't want that. So you need very good monitoring, in order for you to tackle these problems. And then why does EDA matter for African startups? And one reason is unreliable internet. Even like our experience today, our experience of glitches in my internet. So the thing with event-driven architecture is that because it's not tightly coupled, because it's asynchronous as well, when your event produces an event, it does not need to wait for a response immediately. The event just goes to the broker or the queue. It just queues up in the broker, and then whenever the consumer is ready to like process that event, the broker sends it to the consumer. So let's say you're having some sort of internet connection problem, or like it's not reliable at the moment. It's not going to your whole application is not going to go down, or let's say that particular user's request is not going to go down. Yes, it might experience some latency or lag in this case, but then it will still go through, it will still be processed. And like I just explained, EDA provides resilience through messaging queues, and then transactions still persist, even with connectivity issues. And then for scaling purposes, the African market is growing rapidly. We need to also handle like sudden traffic spikes, during festive seasons and like viral moments. So event-driven architecture just allows for all this with independent scaling of every single component in your application. Next slide, the benefits of EDA. With EDA, you can scale and fail independently by decoupling the services. We just need to be aware of the event router. You don't Each of these services don't need to be aware of themselves. You just need to have a connection to that event router or your broker in this case. So this ensures that the services remain operational even if one service fails. Like the example I gave, um, if let's say the registry part of your service is down, so you can't register new users, but you already have existing users, so the existing users can still perform certain functions on your application without the whole application going down. But if it was in Monolith and you can't register users, the whole application will go down just because that one service is down. And then you can develop your agility. It's event-driven architectures eliminate the need for custom code to pull, filter, and route events. The event router automatically just filters and pushes the events to consumers without any need for heavy coordination between the producer and then the customer services. So it just speeds up your whole development process pretty much. Um, yeah, and so we have some challenges and pitfalls of event-driven architecture. And the number one challenge is complexity. Event-driven architectures with microservices can quickly get very complex. That's number one. That's like a very very known fact because like the thing with microservices is that every service is separate. They're all decoupled. So like you could have a separate repo for one service and then you have another repo for like 10 other services. So you all have to like tie these repos together as they are so in a loosely coupled way, but they have to also still communicate with each other. And that's a very complex system compared to your request response driven architecture, whereby everything is just in one application. Your application just runs on one service in one server. That's as easy as it gets pretty much with software development. You know, you have your requests, everything is just compact pretty much. So it's complex in that regard. And then debugging and monitoring is also tougher because you have to now monitor like multiple services rather than just having to monitor one service. So like if your application is down from a particular point, you can just go in to the application and see that okay, yeah, this is what is at fault. Although like you have to still go through the whole testing and redeploying uh, process, which is longer with your event-driven architecture, but in a monolith, it's easier to debug and it's easier to just monitor your system. And then it's easy to forget about back pressure. Like back pressure pretty much occurs when your event producer is producing more events than your consumer can process. That's pretty much what back pressure is. So like in EDA, if a producer is generating events faster than the consumer can process them, it just leads to like resource exhaustion or system crashes. So you have to implement some sort of load balancing to handle the back pressure on your system and ensure that the system just remains responsive and it remains stable over time. And you also have idempotency. So idempotency just pretty much ensures that processing the same event multiple times just use the same result as processing it once. In EDA, this is just very essential to prevent duplicate transactions or data corruptions, and especially when you're working on, let's say, financial applications like a banking application or a payment solution. You don't want someone to like have a double spend, like send money twice or something. So very very straightforward solution to this is catching your systems. So with catching now, you could you could with catching your systems now, you could I what's the word for it? You could create different IDs for each event. Let's say you have an event with an ID one and then an ID two. So like catching that event now, if you're sorry, catching that event now, if your system is having some downtime, it's easier for your system to okay look in the cache and see that okay an event has already been produced like by this and it hasn't been processed yet. But then the thing with catching is that catching does not 100% solve the problem because you can't obviously catch every single event, so you're going to be checkpoints within your event broker. So like it's only redundant to a point where your broker has catched an event that has not been produced yet. So that has not been processed yet. Sorry. So that's just the thing with catching your events, and then you have your eventual consistency. Eventual consistency, pretty much, you know, when events when events are processed asynchronously, you need to achieve eventual consistency as temporary discrepancies can just occur between these components, and then let's say like outdated information can be displayed to the users. So with eventual consistency, your whole system has to agree on a particular like data to be displayed. And then because your system is a microservice and is loosely coupled, um, it's because the system is loosely coupled as a microservice, it's tougher to agree on one particular state of data to show to the users, whereby with your monolith application is just okay, everything is just in-house, and then since everything is in-house, you could what's the word for it now? Since everything is in-house, it's easier for your system to just agree on one state of data as opposed to having multiple state of data for your event for your application due to it being a microservice. So yeah, on to the next slide. Best practices for event-driven architecture. You have your event design and error handling and monitoring. So with event design, you want to use clear naming conventions. You want to include all the necessary metadata to your events and then version your event. And then with error handling, you want to also monitor failed event and like have some clear retry policies. So okay, if an event fails, like what's the policy? Do we retry this event or do we like discard it and like send the message to the user, like let's say by email? Is there like an email consume, let's say like an email service that's the consumer of that event now that's listening for it, and like, okay, does it go through? If no, send an email to the user. Now, okay, the event was not processed. Let's say you tried to book something and then your booking was not completed, or do we retry the booking? So like that's like an internal policy that you have to decide within your application. And you also have monitoring. So you want to track your event flow and then monitor your queue length. That's the queue length inside your broker. So you want to monitor and see that, okay, um it doesn't get too long. That's pretty much, if your queue lengths are getting too long, that's an indication of back pressure, because your producers now are producing way more events than your consumers can consume, or in this case can process. So that's a serious indication of back pressure. It might just be time for you to like consider scaling up your event, to scaling up your application, either horizontally or vertically. And then you also want to set up alerts for your monitoring systems. Just in case anything is wrong, maybe you could have some internal monitoring service that's just running health checks. And then if a particular service is down, you can alert the engineers and tell them, okay, there's something wrong here. And then yeah, with development tools, you have Apache Kafka. Apache Kafka, these are just event brokers. Apache Kafka is used by LinkedIn and Uber. You also have RabbitMQ. You can use that to build a very simple event-driven architecture-based system. But RabbitMQ, you can also use that for message-driven architectures as well. So it's just a very very simple free tool that you could just use for let's say a basic architecture. But if you want to scale, then you have to consider services like Kafka or AWS Event Bridge. The Event Bridge is more like a holistic solution. It's like an all-in-one solution for your event-driven architecture with AWS. That's like if you're running your system on AWS. And then monitoring, you have the usual culprits, Prometheus, Grafana, and then CloudWatch. That's for monitoring your systems. Then a couple reward examples of event-driven architectures. You have e-commerce platforms, you have ride-sharing apps, social media platforms, IoT services, and then video streaming platforms, and banking systems as well. These all use event-driven architecture. Your typical e-commerce platform, when you place an let's say you place yes you add you create an event that adds an item to a cart, or your ride sharing application, when you request for a ride, that's an event that's fired out there. In the social media platform, once you send the message to someone, that's an event. Uh, Video streaming platforms, you like a video, you send an event to the recommendation algorithm, you play a video, you post a video, it's taking notes of each and every single one of these events. And then your banking systems as well, when you send money to someone, there's a send money event, and then you receive a let's say a transaction alert. That's like that's coming from, let's say, the notification service that's acted upon that event, that okay, there was a ceremony event, and then it goes through your messaging queue and then goes to the service, and then that sends you an email. So that's like an example of it in banking systems. So with these examples, these are just pretty much heavy hitters. So if you want to get your next unicorn out there, you need to consider using event-driven architectures. And then thank you so much for having me today, guys. Thank you so much for listening to my session. And if you want to find me, I'm on LinkedIn at Edozie Chimaobi. That's just my name. Twitter at OXMobi, and my dev tool where I occasionally write articles at OXMobi. So now I'll just throw the session open. If you have any questions, you can let us know, so we could just address that before we call it a day.
Thank you very much, Moby. It was definitely a great session. I see some comments from Noah. Thank you very much. Noah has been really active in the chat, including giving some tips for you how
Yeah, the whiteboard. Yeah.
to zoom in the diagram. I would say probably see just a few comments about is definitely event-driven architecture is really powerful, but of course it's always important to assess the nature of the project and the solution we want to build, because there are some scenarios that definitely we cannot apply fully the concept of event driven. There are certain scenarios that we need to be using the nature, the
Monolith,
synchronous, the traditional synchronous nature, okay, including,
yeah,
for example, if you are doing a payment, of course, you need to wait for the payment to be completed and get the message there that it was successful. But of course, if you are doing an order, probably in Amazon as an example, that means you can, submit the order, and then once you receive the order, you can initiate an event-driven system that will propagate and will do many different actions, including generating voice and
yeah.
update stock
This
and
stick stuff.
dispatch the items, everything,
Yeah.
in a reaction of an event, in this case, a new order, So, but definitely this is a really important topic, and as always, this touch an important factor, which is the cost that many organizations try to not only about network, but also cost, because cost is a major factor for many organizations using clouds. That's why it's important for us to be innovative and smart the way we design our solutions to minimize costs, while, of course, uh, maximizing the value provided by those solutions. I think Noah has a question. Noah, feel free to just share your question in the chats if you want, no problem. Um, we are here for that. In the meantime, Moby, really great session, I guess. As far as I remember, it's your first time participating on the Cloud Venture Runs, right?
Yes, yes, yes.
Okay. I hope it's the first of many. You are always welcome. And as I always say, everyone is welcome to contribute. So if you have something valuable that you want to share with the community, you can use our call for speakers page. I'll be actually sharing the call for speakers page there in the in the chat. Okay, so you can use the call for speakers page to submit your session, book your slots, and pretty much come up to share the knowledge with the community. Okay, so we have a question from Noah, so I'm going to just show there in the screen so everyone can follow it. How can EDA facilitate indigenous African apps that require a complex level of language comprehension, an app that address a cooperative of local farmers?
Okay, yeah. So now to address your question, and just repeat it again for everyone else here. It says, how can event-driven architecture facilitate indigenous African applications that require a complex level of language comprehension? That is, for example, an app that addresses a cooperative of local farmers.
Mm-hmm.
Okay. Well, with language comprehension, what I think you mean here is, let's say, a couple of people that speak different languages, and you also have like a translation service. I hope I'm right.
Yes.
Um, so yeah, with event-driven architecture, so now I'm also considering that you have multiple languages that you're translating between. It's just not like let's say an English to say Swahili. You also have like English to Yoruba, English to Swahili, all within the same application. So event-driven architecture could help. I feel like that might just be one of the better solutions to this, because you could decouple each language and have a microservice that would be listening, or like that would be handling each and every single one of these languages. Let's say your Swahili is handled by one microservice, English is handled by another microservice, and then say whatever African language, let's say Sosa is handled by another microservice. Now, what will happen is your messaging queue would, or like when a prompt is given, and that will fire an event, and then it goes to your messaging queue, and your messaging queue now would have to route that prompt based on what language is being spoken in this case, and then you have to now wait for the consumer to process that language and make a translation and then send it back. you know with, if it was like a one language, let's say English to Swahili, I would have said, okay, let's just do that with the monolith, where it's just like, okay, you send the request and then it translates it and like gives you a response. But because we're like handling multiple languages here, it's probably more feasible to use an event-driven architecture or a microservice, to facilitate this application that you're trying to um bring about in this case. So yeah, an event-driven architecture probably could work in this scenario, where you you have different microservices that are handling different languages, and then you need them to you know you need them to talk to each other. You need a way for them to like be coupled together, and then that's where your event-driven architecture comes in. Where your messaging queue would be able to identify a language and then send it to the particular consumer that's supposed to translate that language, and then you should have a notification service or like a response service, that would give the translation back to the listener in this case. So yeah, I hope I answered your question. If you still
Yeah.
want any clarity, I could touch more on that.
I would just say, of course, just to clarify on that, because probably it may be a bit confusing to visualize it. Of course, you would not have physically different microservice with different code base, because then you would be replicating code base, which is unnecessary. Instead, what you can have is just one single code base parameterized that you, for example, you could send the language as a parameter with the request with the original text, and then you could spin up multiple instances of that code base to multiple microservice to then just translate the language and return the
The translation.
return the translation. You know what I mean? So, for example, in a perspective of, for example, imagine a Kubernetes, you would just have an image for a translator parameterized, and then you would just create multiple containers for each of the language to translate and return the response. And that means you would be efficiently do the translation, because it can scale as much as you
That's
need,
all that I want,
and
yeah.
you avoid replication. Okay, so you don't need physical, for example, functions running separately and doing pretty much the same. You know what I mean? Because it's all about translation essentially. Um, yeah, I think we have Damu as well saying great session, Edozi. So thank you very much. I hope you guys all enjoyed the session today. We will be back next week for another great session about semantic kernel for Java. This is an important topic for those that want to learn more about AI and the latest updates related to, in this case, semantic kernel, which was released by Microsoft, as you guys know. But in this case, we have Juarez talking about how to use semantic kernel with Java. Okay. Um, Moby, thank you very much. It was a great session. Pleasure to have you here. I hope you enjoyed the experience.
Yeah. Thank you so much for having me as well.
Thank you very much, and feel free to, of course, this session will be live on YouTube. So if you want to follow up, feel free to just share the session with your contacts and peers on social networks, including LinkedIn, and that means it will help as well share this session with more people so they can watch it and learn from your session. Okay. And in the meantime, wishing you all a great day. I hope you stay well and safe, and see you next week.
All right.
Okay.
See you guys next week.
Take
Thanks for
care. Take care.
the
Thank you very much.
Thank you.